Here are 14 practice problems on angles and triangles. As per usual, I'll link these questions and the answer key in the description, so if you want to work ahead, you can go ahead and do so. But if you need a little bit more help, I will be going through every single question. Or if you need further clarification, feel free to ask me. Anyways, let's get started with question number 1. In the figure, AC is equal to CD. So that means that this side is equal to this side. Now we have a triangle with two equal sides, making it an isosceles triangle. And remember, in isosceles triangles, the two base angles, so this angle right here and this angle, are congruent to each other. They're equal. Let's keep reading. The measure of angle EBC is 45 degrees. So here's EBC. That means that this angle right here is 45 degrees. Now let's continue. And the measure of angle ACD is 104 degrees. So here's ACD. That means that this angle right here is 104 degrees. What is the value of x? So first up, let's find out what these two angles right here are. Now remember, they're equal to each other, so let's represent them as A for angle. That was pretty good, right? Alright, anyways, you should also remember that all the angles in a triangle add up to 180 degrees. So let's focus on this triangle right here. We have angle A, so A, plus another angle A, plus 104 degrees. And this should be equal to 180 degrees. Now let's solve for A. You could do this by hand, or I'm gonna put it in desmos. A plus 104. Instead of an equal sign, you want to put a tilde. 180. And we get that A is equal to 38 degrees. So let me delete all of this real quick. We know that A is equal to 38 degrees, so 38 degrees here and 38 degrees here. Now to solve for x, we can use the exterior angle theorem. And the exterior angle theorem states that, what color should I use? It states that the two interior angles, so this angle right here and this angle right here, added together will equal the exterior angle, so this angle right here. Now that basically means that 45 degrees plus 38 degrees is equal to x. And now to solve for x, add them up. Okay, I'm not good at mental math, hold on. Alright, x is 83 degrees. So that is our answer. Question number 2. In the figure shown, points Q, R, S, and T lie on line segment PV, and line segment RU intersects line segment SX at point W. The measure of angle SQX is 48 degrees. So here's SQX. That means that this angle is 48 degrees. Let's keep reading. The measure of angle SXQ is 86 degrees. So here's SXQ. That means that this angle is 86 degrees. Let's keep reading. The measure of angle SWU is 85 degrees. So here's SWU. That means that this angle is 85 degrees. And lastly, the measure of angle VTU is 162 degrees. So here's VTU. That means that this angle is 162 degrees. What is the measure in degrees of angle TUR? So here's TUR. That means this angle is what we're trying to find. And we'll label this as U because here's the U. Now, first up, let's focus on this triangle here. Triangle SQX. So this one right here. Now remember, all the angles in a triangle add up to 180 degrees. So that means that the purple angle, 48 degrees, plus the blue angle, 86 degrees, plus our missing angle, angle S, is equal to 180 degrees. Now let's solve for angle S. And I'm gonna just put this in desmos. Instead of an equal sign, you want to put a tilde. And you get that angle S is equal to 46 degrees. So that means that this angle right here is 46 degrees. Next up, we now want to find the measure of angle R. So, what color should I use? I'll use red. We're trying to find this angle right here. Now, we can find this measure by using the exterior angle theorem. So, we're going to be looking at this right here. And the exterior theorem states that the two interior angles, this angle right here, and this angle, will equal to the exterior angle, which is this angle. So basically, angle R, which is what we're trying to find, plus 46 degrees is equal to 85 degrees. Now let's solve for angle R. I'm not good at mental math, so instead of an equal sign, you want to put a tilde, and then 85. I have no idea why I did that. I could have just done 85 minus 46. Anyways, that means that angle R is equal to 39 degrees. Now we have every color in the rainbow and all the components we need to find angle U. So we'll be looking at this right here. And to find angle U, we can use the exterior angle theorem again. So once again, the exterior angle theorem states that the two interior angles, so this red angle and angle U, added together will equal the exterior angle, so this pink angle right here. That means that 39 degrees plus angle U is equal to 162 degrees. Now let's put this in desmos the shorter way. And we get that angle U is equal to 123 degrees, making that our answer. Question number 3. Intersecting lines R, S, and T are shown below. What is the value of X? So we're trying to find angle X. But first things first, let's find out what this angle is. And I'll call that angle A. Now what we have here is a linear pair, and all that means is that these two angles added together equal 180 degrees. So 106 degrees plus A is equal to 180 degrees. Now let's solve for angle A, and we get that angle A is equal to 74 degrees. So this angle is 74 degrees. Now to solve for angle X, we can use the exterior angle theorem. So once again, we're going to be looking at this right here. And the exterior angle theorem states that the two interior angles, so 74 degrees and 23 degrees, added together will equal angle X. So once again, 74 plus 23 is equal to X. And we get that X is equal to, 97 degrees. Question number 4. In the figure above, line MQ and line NR intersect at point P. NP is equal to QP. So that means that this side and this side are equal to each other. And MP is equal to PR. So that means that this side and this side are equal to each other. And now we have a triangle with two equal sides, making it an isosceles triangle. And remember, in an isosceles triangle, the two base angles, so this angle and this angle, are equal to each other. They're congruent. What is the measure in degrees of angle QMR? QMR, we're trying to find the measure of this angle right here, which I'll call angle M because of the M. Now remember, this angle is also congruent to this angle, so I'll also label the angle on the right as angle M. First things first, let's find the measure of this angle right here, which I'll call angle P because of the P. Now we have a linear pair here, and all that means is that these two angles added together equal 180 degrees. So P plus 60 is equal to 180, and we get that angle P is equal to 120 degrees. You should also remember that all the angles in a triangle will add up to 180 degrees. So looking at this green triangle, angle M plus 120 degrees is equal to 180, and we get that angle M is equal to 30 degrees. Question number 5. In triangle ABC, the measure of angle B is 90 degrees. Alright, so here's our right triangle ABC. Let's keep reading. And line BD is an altitude of the triangle. So we have an altitude going from B to D, and this will create two new right angles. The length of line AB is 15, so that means this line right here is 15. And the length of line AC is 23 greater than the length of line AB. So that means this line right here is 15 plus 23, which is 38. What is the value of BC over BD? Now we have a set of similar triangles here, so let me separate those so you can see them better. Here are the two similar triangles. On top you have triangle ABC, which is similar to triangle BDC on the bottom. This means that their sides are proportional to each other. Now to find out which sides are proportional to each other, you want to keep this rule in mind. The shortest side will go with the shortest side. So let's look at triangle ABC on top. The shortest side in triangle ABC is this side right here. Now let's look at triangle BDC. The shortest side is going to be this side right here. This means that side AB will be proportional to side BD. So we can call side BD 15 as well, because they are proportional to each other. Next up, the longest side will go with the longest side. So the longest side in a triangle is always going to be the hypotenuse. So if we look at triangle ABC, that's going to be this side right here. And then if we look in triangle BDC, that's going to be this side right here. Now it may look like this side is the hypotenuse, but you have to remember the hypotenuse is always on the opposite of the right angle. So once again, it's going to be this side. That means that side BC is going to be proportional to side AC. So we can write this as 38. Now all that's left is to find the value of BC over BD, which we pretty much already have done. BC is 38, and then BD is 15, making our answer D. Question number 6. In triangles ABC and DEF, angles B and E each have measured 27 degrees. So angle B and angle E are both 27 degrees. And angles C and F each have measured 41 degrees. So angle C and angle F are both 41 degrees. Which additional piece of information is sufficient to determine whether triangle ABC is congruent to triangle DEF? Now there are 5 proofs for congruent triangles. You have side angle side, side side side, angle side angle, angle angle side, and hypotenuse leg. Now for all these proofs to work, you need to have pairs of corresponding sides or angles that are equal. So basically, you need to have equal sides and angles in both triangles. However, if you go ahead and look at answer choice A and B, they only give you an angle or a side in one triangle. We're missing information about the other triangle, so it can't be A or B. Now let's look at C. The lengths of side BC and EF. So theoretically, let's say we did know the side lengths of BC and EF, and let's say they were congruent. We have an angle, a side, and an angle, side, and angle. That means that the approved angle side angle would apply, so C would be your answer. Now D would obviously also not be your answer because they only give us info on 2 sets of equal angles. So we have an angle and an angle. That would be the angle-angle proof. However, the angle-angle proof only works for proving similar triangles. It doesn't work for proving congruent triangles, so you would need more information. Question number 7. In triangles LMN and RST, angles L and R each have measured 60 degrees. So angle L and angle R are both 60 degrees. Ln is equal to 10, so this side is 10, and RT is equal to 30. So this side is equal to 30. Which additional piece of information is sufficient to prove that triangle LMN is similar to triangle RST? Now there are 3 proofs for similar triangles. You have angle-angle, side-angle-side, and side-side-side. Let's go ahead and take a look at our answer choices and see if any of those proofs would apply after using that new information. First up, answer choice A, MN is equal to 7 and ST is equal to 7. So that means that both MN and ST are equal to 7. Now we have an angle, a side, and a side. Angle side side is not one of our proofs, so A isn't going to be the answer. B. Mn is equal to 7 and St is equal to 21. We already had information on these two sides, and once again we'd have an angle, a side, and a side. Angle side side is one of our proofs, so B won't be our answer either. C. The measures of angle M and S are 70 degrees and 60 degrees respectively. So angle M is 70 degrees and angle S is 60 degrees. Now we have an angle, and a side. Angle, angle, side isn't one of our proofs, so C isn't going to be our answer either. Now we know D is obviously going to be the answer, but let's go ahead and prove it. The measures of angles M and T are 70 degrees and 50 degrees respectively. So angle M is 70 degrees and angle T is 50 degrees. Now you might get a little confused here because you have an angle, and a side in the left triangle, and then you have an angle, a side, and an angle in the right triangle. Well, you should remember that all the angles in a triangle add up to 180 degrees. So if we take a look in our left triangle, 60 degrees plus 70 degrees plus this missing angle, which I'll call x, is equal to 180 degrees. And solving for x, we get that it's equal to 50 degrees. So this missing angle is equal to 50 degrees. Now we have two angles that are congruent to each other in both triangles, which means it's the angle-angle proof, so that would prove that the triangles are similar. Question number 8. In the figure above, what is the length of line NQ? So we're trying to find the length of this line right here. Now we did have two triangles that looked like this image here earlier, and I did mention that they were a pair of similar triangles. However, I didn't explain why, so my bad on that part. I will explain why this here is also a set of similar triangles. There are three proofs for proving similar triangles. You have angle-angle, side-angle-side, and side-side-side. Now here in these two triangles, the proof that would apply would be angle-angle. And what this means is that there should be two pairs of angles that are equal to each other. So the first pair would be both of these 90 degrees, and then the second pair would be this angle right here. Because you notice that in this triangle right here, and in this triangle, they both share that angle, which means it's going to be the same measure. Alright, I went ahead and separated the two similar triangles. On the top you had triangle MNP, and on the bottom you had triangle QNP. And once again I want to point out you have the right angle and angle P in both triangles, making the angle-angle proof work. Now before we do anything else, you should notice that the top triangle is a 3, 4, 5 triangle, which means that the length of this hypotenuse is 5. Now if you didn't know that, that's completely fine. You probably noticed that there's a missing side in a right triangle, which means that you could have used the Pythagorean theorem to find that out. Once again, the Pythagorean theorem is a squared plus b squared equals c squared. So 3 squared plus 4 squared equals c squared. Now let me put that in desmos. Instead of an equal sign, you want to put a tilde, and you get that c is equal to 5. Now we can finally move on to the next step. So here we have a pair of similar triangles, which means that their sides are proportional. Now to find out which side is proportional to what, you always want to follow this rule. And this rule is that the shortest side will always go with the shortest side. So here in the top triangle, the shortest side is going to be this one right here. Now you could tell by looking at it, or you could also see that it has the smallest length. Now in the bottom triangle, the shortest side is actually this one. Now I know it's kind of hard to tell in the drawing I made, but if you look in the original figure, it's a lot more obvious that it's the shortest side. This also happens to be the side that we're looking for, so let's call this x. And while we're at it, let's also set up a proportion. So on the left side will be the top triangle, triangle MNP, and then on the left side will be the bottom triangle, triangle QNP. On the numerator will be the shortest side, so in the top triangle that's 3, and then in the bottom triangle that's x. Next, the longest side will always go with the longest side. So the longest side in any triangle is always the hypotenuse, and that's going to be across from the 90-degree angle. So in your top triangle, the longest side is this side right here, which is 5. And then in the bottom triangle, the longest side is this side right here, which is 4. And now all we have to do is solve for x, so let's go ahead and put that in desmos. And you get that x is equal to 2.4, making your answer C. Now, I know I usually use a tilde, but this time I kept the equal sign because we use the letter x. If you use x or y, you have to use an equal sign. Otherwise, if you use any other letter, you want to put a tilde. Question number 9. Triangle XYZ is similar to triangle RST, such that x, y, and z correspond to r, s, and t respectively. The measure of angle z is 20 degrees, and 2xy is equal to rs. So let's call xy 2x, and that would mean rs is equal to x. What is the measure of angle t? So we're trying to find this angle right here. Alright, so here we have a pair of similar triangles, and in similar triangles, corresponding angles are congruent. So the angle that corresponds to angle t is going to be angle z. And once again, corresponding angles are congruent, which means that angle t is also going to be 20 degrees, so our answer is C. Question number 10. In the figure above, RT is equal to TU, so this side is equal to this side. Now we have a triangle with two equal sides, making it an isosceles triangle. And you should remember that in an isosceles triangle, the two base angles, so this angle and this angle, are congruent. What is the value of x? First, let's focus on that isosceles triangle. So you should note that all the angles in a triangle add up to 180 degrees, and we also know that these two base angles are congruent. So we label both of them as A for angle. That means that A plus 114 is equal to 180 degrees. And now let's solve for A. Instead of an equal sign, you want to put a tilde. And you get that A is equal to 33 degrees. Alright, now to solve for x, we can use the exterior angle theorem. Now we're going to be focusing on this. And once again, the exterior angle theorem states that the two interior angles, so this angle and this angle, added together will equal the exterior angle, which is x. So 31 plus 33 is equal to x. That means that x is 64, making our answer C. Question number 11. The area of triangle ABC above is at least 48 but no more than 60. So the area is at least 48 but no more than 60. If y is an integer, which means it's a number with no decimals, what is one possible value of x? First things first, let's find out what the area of this triangle is. So we're dealing with triangle ABC, and remember, even though I don't have the reference sheet up, the formula for the area of a triangle is 1/2 base times height. The base is going to be this entire side right here, and I kind of cut it off, but that's going to be 5 plus 7, which is 12, and the height is going to be y. Now if we go ahead and simplify that, that means the area is going to be equal to 6y. And now let's substitute this into that inequality. So 48 is less than or equal to 6y is less than or equal to 60. And now let's get y by itself by dividing the entire thing by 6, and we get that 8 is less than or equal to y is less than or equal to 10. Alright, so now we know that y is a number between 8 and 10, so that means it could be 8, 9, or 10. It really doesn't matter which number you choose, but I'll just choose 9. So we can put y is equal to 9. Alright, now that we finally finished solving for y, we can start solving for x. So we actually have a pair of similar triangles here, and this is proven by the angle-angle proof, which means that there's two pairs of congruent angles. We have these two right angles right here, and then we also have this angle A, which is shared by both the big triangle and the small triangle. Alright, so I went ahead and separated the two similar triangles so you could tell them apart a little bit easier. On the left you have the smaller triangle, and on the right you have the bigger triangle. Once again, I want to point out that You have this right angle and this right angle, and then you have the angle A's, making it a pair of similar triangles. Now, in similar triangles, the sides are proportional, but to find out which side is proportional with what, you always want to use this rule that the shortest side goes with the shortest side. So here in our left triangle, the shortest side is going to be this side right here, and that's going to go with the shortest side in the right triangle, which is this one. So let's go ahead and set up a proportion. On the left side will be the smaller triangle, on the top will be the shortest side, and then on the right will be the larger triangle, and once again on the top is the smallest side. Now let's move on to the middle length size, I guess. So in the left triangle, that's going to be this side right here, and in the right triangle, that's going to be this side right here. So let's put this into the proportion, 5 and 12, and now all we have to do is solve for x. So let's put this in desmos. Now we get that x is equal to 3.75, so that means our answer is 3.75. Question number 12. In triangle RST, angle T is a right angle. Point L lies on line RS. Point K lies on line ST. And line LK is parallel to line RT. If the length of line RT is 72 units, the length of line LK is 24 units, and the area of triangle RST is 792 square units, what is the length of line KT in units? So they're asking us to find the length of line KT, which is this side right here. So here we have a pair of similar triangles, and this is proven by the angle-angle proof, which means that there's two pairs of congruent angles. The first pair is going to be these two 90-degree angles, and then the second pair is going to be this angle S right here, because it's shared by both the big triangle, RST, as well as the smaller triangle, LKS, which means that they have the same measure. Alright, so I went ahead and separated our two similar triangles so it'll be a little bit easier to see them. Once again, I want to point out they have the right angles and also angle S. Now, it's given that the area of triangle RST, which is this top triangle right here, is 792 square units. The formula for finding the area of a triangle is 1/2 base times height. We know that the height is 72, and we're trying to find what the base is. So let's plug in our known values. 792 is equal to 1/2 times the base times the height of 72. And now let's solve for the base. You could do this by hand, or I'm gonna just put it in desmos. Instead of an equal sign, you want to put a tilde. And we get that the length of the base is 22. Alright, now in similar triangles, the sides are proportional, but to find out which side is proportional to what, you want to follow the rule that the shortest side goes with the shortest side. So here in the top triangle, the shortest side is this side right here, and then in the bottom triangle, the shortest side is this side. That means that 72 is proportional to 24. Let's go ahead and set up a little proportion. The left side can be the top triangle, RST, and the right side can be the bottom triangle, LKS. In the numerator will be the shortest side, so that's going to be 72 and 24. Next, the middle length side will go with the middle length side. So that means that in the top triangle, this side is proportional to this side in the bottom triangle, which we'll just label as S for now. Let's put this into the proportion, 22 and S. Now let's solve for S by putting it into desmos. Instead of an equal sign, you want to put a tilde, and you get that S is equal to 7.333. Now whenever you have a repeating decimal like this, what you can do is just type a bunch of that repeating decimal, and then it gives you the fraction form. So S is equal to 22 over 3. Alright, we just found all of these side lengths, but we still haven't found the length of line KT yet. So let's move back to the main triangle with both of our similar triangles included. So first off, we found out that line ST is equal to 22. So that's going to be this entire line right here. We also found out that line KS is equal to 22 over 3. So that's this line right here. Okay, and I think you can see where I'm going with this. To find line KT, all we gotta do is subtract 22 over 3 from 22. So 22 minus 22 over 3 gets us our answer of this repeating decimal. But you can just click this fraction on the left and it gives you the fraction of 44 over 3. So that means our answer is 44 over 3. Question number 13. In the figure, parallel lines Q and T are intersected by lines R and S. If A is equal to 43 degrees and B is equal to 122 degrees, what is the value of W? So here we have two parallel lines intersected by two transversals, and there are a few ways you could go about doing this. There's a linear pair right here, and that's two angles that are next to each other, and these two angles will add up to be 180 degrees. So x plus 122 is equal to 180, and that means that x is equal to 58 degrees. Then you have a pair of vertical angles here, and vertical angles are just angles that are across from each other, and they'll have the same measure. So that means that that angle will be 43 degrees as well. Now to find this last angle, which I'll call angle A, you'll notice that there's a triangle here, and all the angles in a triangle will add up to 180 degrees. So 58 plus 43 plus angle A is equal to 180 degrees. And now let's solve for angle A. Instead of an equal sign, you want to put a tilde. And you get that angle A is equal to 79 degrees. Then, these two angles are alternate exterior angles. And that's because they are on the exterior or outside of the parallel lines, and they're also on alternate sides or opposite sides of the transversal. So, alternate exterior angles will have the same measure, so that means this angle down here will also be 79 degrees. And then lastly, you have one final linear pair, so all three of these angles added together will equal 180 degrees. So W plus 79 is equal to 180. Now let's solve for W. Instead of an equal sign, you want to put a tilde. And you get that W is equal to 50.5 degrees, making that our answer. Question number 14. In the figure above, BD is equal to 6, and AD is equal to 8. What is the length of line DC? So we're trying to find the length of this line here. So here we have another pair of similar triangles, but this time we're going to be focusing on different triangles compared to the previous questions. In this question, we'll be looking at this triangle on the left, as well as this triangle on the right. Now the reason these triangles are similar is because they share this side right here. This side BD cuts the bigger triangle into those two similar triangles. So whereas in the previous questions we were focusing on the big triangle and one of the smaller triangles, this time we'll be focusing on the two smaller triangles. So I went ahead and separated the two similar triangles. And remember, in similar triangles, corresponding sides are proportional. But to find out which side is proportional to what, you always want to follow this rule, that the shortest side will go with the shortest side. So here in our left triangle, the shortest side is this vertical side right here. Now normally you would be thinking that, oh, this side will obviously correspond to the other side that is also 6 on the triangle on the right. But remember, the shortest side goes with the shortest side. And in the right triangle, the shortest side is actually this side here on the bottom, which we'll label as S for side. Now let's go ahead and set up our proportion. On the left side will be the triangle on the left, which is triangle ABD. And on the right side will be the triangle on the right, which is triangle DBC. On the top of the proportion will be the shortest side. So in the left triangle, that's side BD, which has a length of 6. And on the right triangle, that's going to be side DC, which has a side measure of S. Next, the middle length side will go with the middle length side. So here in the triangle on the left, the middle length side is going to be this side right here, side AD. And on the triangle on the right, the middle length side is going to be this side right here, which is side DB. So let's go ahead and put that in our proportion. The middle length side in triangle ABD is side AD with the length of 8. And the middle length side in triangle DBC is side DB with a length of 6. Now all we have to do is solve for S. Instead of an equal sign, you want to put a tilde. And you get that S is equal to 4.5. Alright, that was 14 practice problems on angles and triangles, and Desmos is going to be a big help in solving for those missing angle measures or side lengths. Now while there are only 14 questions, it actually ended up taking me hours to record this because I hate similar triangles. They're definitely my least favorite topic on the SAT, so I really struggled finding a way to explain them. Now that we've gone through a couple of these similar triangle questions together, and you kind of get the flow for how they go, I want to go more in depth on my thought process in certain steps. And hopefully this will clear up any questions that you might have. So here in this question right here, our very last question, we chose to use these two smaller triangles as our similar triangles, whereas in the previous questions, we would use the larger triangle. And the reason we didn't use the larger triangle in this question is really just because we don't know the side lengths of any side. We don't have information on side AB or side BC, and while we do have information on side AD, that's only half of that side length. We're still missing the other half. Now, I also say the rule that the shortest side goes with the shortest side, the middle length side goes with the middle length side, and the longest side will go with the longest side when you make a proportion. Now you might be wondering, okay, that's great and all, but when are you supposed to use the shortest side, the middle length side, or the longest side in your proportion? And the answer to that is that it entirely depends on what you're given and what you're solving for. So here in this question, they ask us to find the side length of DC. This side right here. And you'll notice that side DC is the shortest side in the triangle on the right, which means that you definitely want to be using the shortest side in your proportion. So that's one down. We know that we need the shortest side in the proportion. Now, are we supposed to use the middle length side or the longest side in the bottom half? We're given information on side length AD, and in the triangle on the left, that's the middle length side. And then in the triangle on the right, we're given information on side BD, which is also the middle length side. So that's why we use the shortest side and the middle length sides in our proportion. Now, in a question like this one, we're given information that the length of side AB is 15. And in our top triangle here, side AB is the shortest side. So that's why in our second triangle, we matched it to the shortest side. Then we're given the length of side AC. And in our top triangle, side AC is our hypotenuse. So that's why we matched it with the hypotenuse in the bottom triangle. Now similar triangles have proportional sides, which means that they multiplied by a certain number to go from one triangle to another. But here in this question, they ask you for the proportion, so that's why we were able to use the same numbers for the side lengths. They didn't actually ask us for the side lengths like they did in the other questions. Alright, so that's basically everything that I wanted to recap in similar triangles. I know that my explanations are a little bit iffy, so if you're still confused, feel free to ask me any questions. We also focus a lot on proofs, so you definitely want to make sure that you know those proofs for similar and congruent triangles. You also want to make sure you're comfortable with your parallel lines and your special type of angles, such as linear pairs, vertical angles, alternate exterior, but also the ones we didn't use in this question, like corresponding, alternate interior, that type of stuff. So it's definitely going to be really helpful to know all those types of angles. And one final thing, you definitely want to make sure you know the alternate exterior angle theorem, which is the two interior angles added together will equal the exterior angle, so the angle on the outside. Alright, that's going to be it. Good luck studying, and I'll see you.